going to start replacing these paper wax capacitors in here. Going to switch gears a little bit from excuse me, from electrolytics and start working on these. I'd like to start with the hardest ones first. Oh boy, I'm just noticing this here. Is that original? Interesting. I'll have to double check that too. It looks a little odd to me. Kind of a sloppy job there with these wires exposed, but who knows, maybe it came that way from the factory. Anyway, looks like the most difficult capacitor in here to change is going to be this guy right here. I'm not sure which number it is on the schematic, but it's wax paper, so it's got to go. And to get there, you notice this coil is sort of in the way of where the leads are going, so this is going to be need to be removed. I'm going to need to looks like there's a lug here, solder. This wire here is soldered to this point here, which goes to the antenna terminals in the back. So I have to cut that and remove these screws. It's an adjustable trimmer, as you can see here. Let me get the light on that in the back. So I looked it up on the schematic and what this coil was, and it turns out it's on the schematic, it's listed as a wave trap trimmer. So something I haven't come across before. So just did a quick look up on what a wave trap trimmer is, and this is on antiqueradios.com, a post, and this is from somebody had asked the question, what's the purpose of a wave trap? And the response from this person was that apparently this is going way back with marine stations sort of overpowering radios, and this trimmer was used to, coil was used to sort of tune out the overpowering, offending station. So what he writes here is coastal stations in the maritime service used high power transmitters in the 200 to 500 kilocycle range to send CW to ships. I think that's referring to like a sort of a Morse code. So if you were near one of these operating at 456 kilocycles, that's what the radios use. You would hear the CW with a 1 kilocycle tone whenever you were tuned into the station. So I guess I've read a little bit. Some people were sort of just taking these out of circuit. I'm not going to do that. I'll leave it in circuit. And hopefully we can trim it. Apparently what you want to do is you want to make that adjustment after you do your alignment. So I'm going to work on getting rid of that and I'm sorry, just removing it temporarily so I can get to that capacitor underneath. So just by removing the nuts from this the post terminals on this wave trap coil, I was able to sort of just move it to the side without having to desolder any wiring. So that's kind of nice. Makes life a little easier here. Hopefully they thought of that when they designed this radio for servicing. It looks like maybe they did. Now I can snip out this capacitor here and put a new one in. And maybe I'll go over that a little bit too with this series. This will turn into sort of a little video about replacing the capacitor and about the wave trap. What I've done is just a real quick drawing showing the capacitor I'm about to remove. This will be a reference for putting the new one back in. By the time this radio is done, I'll have 2 or 3 of these sheets with different drawings I've done on them, showing the position of the capacitors and where they relate, and it just helps me to remember which way they go back in. And also I mark the outer foil side of the capacitor, and this one you can see if you can see it on that capacitor, that black. Let me point to it. That black band right there, and on the others here, the black band, you can see this one even says, if you read that, it's going to say outside foil. So this end is where there's a foil that sort of wraps around the outer portion of the capacitor here and serves to protect it from interference. So it's a shield. And with these old paper wax caps, one side is most likely going to be labeled in this way. And it's a good idea to reorient your new capacitors the same way. It can help with the circuit to sort of maintain the shielding that was in place. So you get, you know, as little interference and hum as possible. There's a trick to that, which I'll show you later. The newer capacitors, unfortunately, they do have the shield, but they don't tend to be marked, and sometimes they can be marked very confusingly. You might actually see sort of a black line or whatever, and you might think that that actually is the outer foil, but most likely it is not. It's some type of marking for another use. So what I've done here is, you can see this is, I've shown that this capacitor, the non-foil end, connects to pin 8 of the 6K7, and the other side connects to a ground, a lug point on the chassis. Very difficult to see here, so you'll have to trust me on that. So I've gone ahead and you know, how do I know that's the cathode point of the tube? Well, if I go and I looked up the tube specifications on this tube, you know, by counting the relationship of the pins on the tube, I went around and I could see it was, you know, 1, 2, 3, 4, 5, 6, 7. And the way that's done is if you have a tube, this is from the back side here, and you have your notch from the bottom side. Let me just draw the pins. You're going to want to go in a clockwise direction. This is a sort of a non-existent fancy tube here. So this would be, if this is your notch, this is pin 1, 2, 3, 4, 5, 6, 7, and 8. So based on the orientation of this particular tube, I was able to determine that it's connected to pin 8, and just out of curiosity, when I looked it up, and you can see that pin 8 goes to the cathode here. This is the filament, the grids, and the plate. And also further looking on the schematic, if you look up the 6K7, and you can see that attached here to the cathode is the capacitor in question. So it turns out that is actually C2. So we can mark that here on our drawing that this is C2. Now, many schematics will also give you the value here, and you can see, you know, one side goes there, one side goes to the ground. So this is definitely the one. The value is not listed here, and oftentimes too, you can then go look on if it isn't listed directly on the schematic. You can sort of look up in the other literature that you happen to find on your radio. You could perhaps go through these lists of parts, and you know, you could go to, for example, condensers. You know, this is the old word for capacitors is condensers, and you could sort of look up the C2 and it'll give you the value. This does not do that. This list that I have here, they're using it for many chassis, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one does not list the capacitor number and the values. So it's kind of unfortunate. I don't really like that. I would have preferred that the values were listed there, just to confirm that we have the right capacitor if we need to go do some diagnosis. Not a big deal, because once we cut that out, we should be able to read the markings on it very clearly and determine what the replacement will be. All right, so I'm going to go ahead and start snipping these wires here for that capacitor and work on putting the new one in. What I'm going to do is, there's so many videos on YouTube about this that'll probably show this better than I will, but I'm going to go ahead and throw my hat in the ring and do a little demonstration myself. What I'm going to do is I'm going to cut the leads of this capacitor right up against the capacitor body. That's going to leave these two longer leads attached to the chassis. Real good idea to do that because it's going to help you remember where your contact points were and where the capacitor went. You're going to clearly see two leads sticking out, and that'll help you to reorient. And that, along with the photos that you took, you please take photos as you go along of everything. The more photos, the better. Video, etc., etc. And my drawing, that'll help us to reorient the new capacitor in position. Just do one capacitor at a time. You don't want to go in here and start snipping them all out. You're going to get very, very confused, most likely, unless you have a much better memory than I do. Okay? All right, I did snip off this end of the capacitor. That's easily accessible to the cutter and for the soldering iron when I want to get it back in there. But looking at this other side, this is a very, very difficult to access capacitor. Most of them aren't going to be this difficult. There's little chance I can get my, let's see it right there, the snippers in there in the first place, and then it's going to be really impossible to solder that. So there is a small board here with this domino style. That could either be a capacitor or a resistor. I believe it's a capacitor. It has a resistor on the other side of it. Here you can see. So that board is definitely in the way, but it looks like it'll be pretty easy to just temporarily lift out. I'm going to unscrew this here, this point, which is connecting this board to the chassis. Let's remove that nut and see if we can't lift this out and get it out of the way. Yeah, I've removed that nut, and this was in position. Remove the nut. This little board just slipped right out of the way, so we're just gonna tuck this to the side for now. And now you can see I have good access to the right here to the ground lug with the capacitor in question's leads connected. So let me remove that and get the new one in there. Here's that capacitor. It's actually labeled Zenith. I'm not sure I've seen a Zenith labeled capacitor before. So this is, excuse me, excuse me, definitely original. And this is a 0.05 microfarad capacitor rated at 200 volts DC. Interestingly, I think the pre-war sets such as this had markings that actually seem to make more sense in the sense that they're the more even increments, whereas this is listed as a 0.05. A modern equivalent, I'm not sure you can still get a 0.05. Well, you can get them, but they're more of a specialty use. Most modern capacitors of this size are going to be listed actually as a 0.047. I've actually purchased a bunch of pre-war capacitors. They weren't made before the war, but they're new capacitors that are designed to match more closely the pre-war capacitors. So instead of having to put a 0.047 in here, I believe I'll actually have a 0.05. Let me just show you. Let me plug this here and go over. I'll show you some of the. I've really stocked up on capacitors, electrolytics. These are electrolytics as well, and some of these orange film capacitors. When I first started doing this, I was you can see them in there, having to order parts as needed, and it could really delay things. So I've just gone ahead and ordered a bunch of supplies so that I have a pretty good stock of semiconductors, also resistors as well. This is actually getting back to the multi-can. This is a 40-40-40 that I did purchase, but I'm not sure why I did not end up using this. Maybe this is a while ago, but I do have this on hand for a previous project that I did not end up using. So let's see. These are new. I just purchased these. This is a bunch of capacitors here. These are labeled post-World War II. I've gone ahead and labeled that post, so that's not... We could use some of these in here. For example, here's the .047. There are a few of those in there. We could use that, but let's do it right. And let's find our bag of pre-war capacitors. Okay, so these are all rated 630 volts. That'll be fine. And I think I have a .05 in there. Yes, we do. Okay, let me get one of those out. This is the replacement capacitor here. Again, a modern equivalent replacement for this capacitor. They're both .05s. The original is rated for 200 volts DC. This newer one is rated for 630 volts. In general, that's really not considered an issue at all. Going higher. In fact, a lot of people really recommend going higher. However, I was watching Shango last night, and he had an interesting observation, and he was starting to wonder if going to much higher values with the voltage on the replacement capacitors is a good idea or not. His thinking is that perhaps if this is rated at 630 volts and it's constantly running at a lower voltage, that it may speed the decay of the capacitor due to it not running at its sort of the voltage that it's designed for. And I guess keeping these things energized helps keep them functioning properly. I think a lot of what happens, as my understanding is that they're not being used and they tend to dry out a little bit more. There's actually a procedure I guess you can do with some of these old capacitors called reforming, not repacking as we did with the electrolytic, but reforming, and it's a process I guess where you slowly re-energize the old capacitors and help to reform them. I guess it kind of gets the old juices flowing again in these and helps to bring them back into spec. Anyway, these radios here that I'm restoring really are not going to get a ton of usage anyway. So whether I put a 200 volt in here or 630 or what have you, either way, it's not going to. These radios will be operated fairly infrequently anyway. It's not like these are going to be getting daily usage. So, but yeah, I thought that was interesting. Again, check out Shango, and a lot of fun to watch, and you learn quite a few things as well as the others that I recommended. So I didn't mention the foil side here. A tip that I learned from Mr. Carlson's lab is to sort of find the foil side on this existing capacitor. So previous capacitors that I've purchased, I have been able to locate the foil side. And let's see with this new batch if these also have an outer shield as well, because we're going to want to mark that on here and put this back in position so it mimics the way this one was oriented with the shield side towards the ground. And that's common that the shield side will go to ground on these. So let me show you a little trick. So finding the foil side involves using, I'm sure there's other ways of doing it, but basically you want to find out find the side that creates the least noise. So what I have here is I have the Radio Shack powered speaker, and this is the input here. So this cable itself is shielded. This is designed to plug into your computer, iPod, etc. And the negative terminal, which is going to be the larger end here, you can see this is a stereo plug. So the top two are left and right. The bottom one is the common ground. The common ground area here is shielded all the way through this cable. So it's used as a connection point, but it also serves to, because it's a sort of the cable connected to this point here wraps all the way around the entire cable, encasing the two positive cables. So that it's kind of like an armor of sorts. It blocks RF, etc. interference from getting through to the into the cable and the wiring, so you have lower noise. So what you want to do is you want to attach your capacitor in such a way that you have the least noise when you're contacting one end to the negative portion and one end to the positive. Now, if I connect this and I listen to the speaker and I hear a buzz, okay, I know that this side is not the grounded side. If I flip it and I connect this side to the shielded portion of the cable and this one to one of the positives, it doesn't matter, and I have less noise, okay, then I know that this is the shielded end, because I'm holding this in my fingers, so I'm acting as an antenna. So if I get less noise, if I'm transmitting less interference is being transmitted from my body through this capacitor and through that cable into the speaker, the one with the less noise is going to be the one that demonstrates that this is that this is the correct shielding side. So then what you would do is you would then mark this with a dot, and that would sort of recreate the negative band on the on the old capacitor. So interestingly, you know, I've done this on, this is another capacitor, this style of capacitor that I've purchased before. I can clearly hear a difference between using one of these ends in this way, and I can definitely find that one end will be quieter than the other. This is a newer batch of capacitors I've bought, and you know what? I can't hear a difference either way. Fortunately, either way, I'm getting no noise at all when I hold it in my hand. So this is, maybe it's a better design, and it's shielded well in both directions. So given that I'm not getting any noise either way, the orientation, I'm just going to go ahead and put this in sort of anyway. Maybe I'll just orient it so that we can read the writing on there well from our position, viewing into the chassis. This is just a quick demonstration. Hopefully you'll be able to pick up the sound on the speaker of one of the capacitors, where I can definitely determine the foil side. So take a listen, see if you can hear this. Very little buzzing. So I suspect that this is the foil side. Now if I reverse it, yeah, I think that's the noisier side. Okay, maybe you can't hear that. I'm actually going to, you may go off view for a second here, but I'm going to put the microphone of this camera right towards the speaker, so perhaps you can hear that. So things may go dark for a bit, but see if you can hear the difference. Okay. Okay, so that's the first orientation, very quiet. So you can sort of hear the difference in the buzz as I apply the capacitor, and that would be the noisy side. Again, now I'm connecting the correct orientation, and you can't even hear the difference as I apply the capacitor. So that would be the correct end. The lead that's connected to the capacitor lead that's connected to the shielded end of the cable, that should be marked as being the shielded portion of the capacitor. Getting ready to prepare the leads on this capacitor for installation. The existing capacitor with the axial leads came out in line horizontally from the capacitor, so we need to do the same here, where these are sort of sticking down. So we're going to bend those into position, but I wouldn't just take those leads and bend them to the left or the right. It's probably fine, but I would probably get into the habit. I like to put the needle nose pliers right at that point and bend from there. That way, you're not disturbing the connection within the capacitor. You don't want to disrupt the integrity of that. So probably a good idea to just grab it like this with the needle nose pliers, and then you sort of bend them out horizontally. So that's what that looks like. When we've bent it out, we're going to get ready to put this in the chassis. I'll do a couple measurements and figure out if we have enough length here. Also, a good idea to use a little spaghetti tubing here to put over your leads to protect these areas from shorting. It's just a mess in there. Look at all those possible places where the capacitor could possibly connect to. So, it could short out in many different ways. Sometimes you can get away without it, but you can see here that they've done the same here with these capacitors. They've put some cables over them to protect them. So the Zenith did a pretty good job in that regard. I've seen some radios where, boy, the leads are just so close, particularly on the high voltage portions of the tubes. I'm amazed. Sometimes I see wires that are just so close together that, my goodness, if a matter of a millimeter could have really caused a great deal of damage and maybe introduced a safety issue as well. So Zeniths have a good reputation. So I see it looks like they've done a good job here. Okay. They're doing a dry fit. The leads on this replacement capacitor aren't quite long enough for me to reach the two connection points and get a good wrap around. So another good reason we left quite a bit of length on the old capacitor remaining on the chassis. That'll allow us to take those leads and connect them this way using sort of like a J-hook. So you can see what I've done here is I've added some little J-shaped hooks using the needle nose pliers here in the capacitor. And just this is sort of a demonstration with the piece of solder mimicking the what's going on inside with the old capacitor leads. So what we'll do is I'll try to form those leads as well into sort of a J-shaped hook, and we'll link them together, crimp them with the pliers, and then solder from there. So I've just added the spaghetti tubing here to the capacitors, give it a little insulation on those leads. So we have just doing one at a time here. It's going to be hard to get the other lead connected without this one in place. So I'm just going to do this lead first. You can see I have created a J-hook on the old lead going to the old capacitor, connecting to the pin of the tube. J-hook there, and that connected to the J-hook on my replacement capacitor. Just bent those down a little bit with the needle nose pliers, made a nice solid mechanical connection there, and I'm going to solder that up. Yeah, so we got a pretty good connection there. Solder took well. Yesterday when I was showing you some of the techniques, soldering techniques, I had the iron cranked up to the 999. For this purpose, I'm using 750 on the temperature for the soldering iron, which worked pretty well. No need to go higher than necessary. You probably could have gotten away with around 700 as well. I switched a while ago to some lead-free solder. I've been trying this out, and I noticed that the surface of the soldering joints aren't quite as shiny with this, and generally sort of a dull sort of a surface on a soldering joint is an indication that you've got a cold joint there. I think that's the term. Whereas the connection is sort of brittle and you didn't fuse together properly. See, I'm finding this. I've had no problems using the lead-free solder. And it seems like I'm getting a very good solid joint, but the surface tends to be a little cloudy or not as shiny with the other. So I think that's just something, a characteristic of the lead-free solder, not necessarily an indication that there's something wrong with the joint. Yeah, I switched to the lead-free only because there's fewer fumes, and I was a little concerned about the lead and the solder. A lot of people don't like using the lead-free solder, but I figured just for my own health, I would give it a try. And so far I've had pretty good luck. I'm going to stick with it. So let's move on to the other side now. All right, so we have our capacitor installed there. Looks good. Just again, bringing up the importance of having a good iron here. I was doing this at using the 750 setting on the soldering iron, and it shows you the difference between each side. The other side was just going to the the pin terminal on the tube, whereas this side is connecting to the a large let's see, soldering lug here. So what I'm soldering to is directly connected to the chassis, and again, as I mentioned, that becomes a heat sink, and the more metal that you have, the harder it is to make a joint. So at the 750, it wasn't really flowing as well as I'd like. So quickly just cranked up the Heiko to the highest temperature, and yeah, that really heated up both sides, including the lug side, so that the solder did flow correctly. And the Heiko is great because you can go between temperatures very quickly. I'll show you here. It's at 750 now. I have it set, the setting P5 is 899. And you'll see just, oh, you have to hit enter, sorry. See how quickly it goes up to temperature. I mean, it's amazing. So very handy, and you can switch temperatures very quickly. So I'm at 899, and then also if we go back to my P3 setting, which is 750, let's see how quickly it goes back down to temperature. And even when you're completely disconnecting the heat from the element, if you want to change tips, that seems to happen very, very quickly as well. It seems like within a matter of 5 minutes or so, you're able to safely change your tip. So yeah, great design on this on the soldering iron. There we go. So as I was preparing the capacitor lead for this the side going to the ground, I noticed this piece of metal down by the chassis, and I thought, geez, is that a piece of solder that dropped in there from when I connected to the first connection? So I pulled it out, and it turns out it's actually a pretty heavy-duty piece of wire here. So this could have been in there from the time of manufacturing and dropped in. I'm trying to look around quickly. I don't see any other use of this type of cable, or it's almost like it's a wire, but it has a sort of like a miniature cable look to it. So maybe that got introduced from a previous restoration or some other way. But yeah, good thing that didn't cause any troubles with short circuits or what have you. Or who knows, maybe it did. At any rate, that's gone. So, when you're working on these things too, just be really careful that you remove any metal debris, any cuttings. If you snip your cables, they can drop into these crevices here. Yeah, you want to really remove them. It's a good idea to actually, as you're cutting, to hold on to the lead that could potentially fly away. Hold on to it, cut with your other side, and then pull it out. If that's not possible, really go back in with your pliers and pull out any little scraps. Oftentimes I find with the solder, if it's a tight spot, you never know. A piece of that solder can actually break off, and you could leave a 1-inch piece of solder in there as well. So be careful about removing that also. All right, so at this point I've showed you the replacement of one capacitor. I'm going to go ahead and work on the rest of these. I'm not going to bore you with the details of replacing all these capacitors. Maybe if when I get to this electrolytic, we'll discuss that and my choice of whether or not to just replace this under chassis electrolytic or to restuff that can. And if anything interesting comes up along the way, I'll be sure to record that. Oftentimes when I'm working on these old chassis, you're in there with the needing those pliers and you're twisting things around, and I kind of feel like the dental hygienist probably feels when she's cleaning my teeth. So interestingly too, I'm finding that it works well to clean off a lot of these dust bunnies in here, and trying to get the wire so you can actually see the correct colors and get all the dust and again 80 years of filth off. The first thing I did is, I brought it in the garage and blow it out with a compressor, being very careful, to keep the PSI to a minimum. And then, you can also use the, sort of a dusting spray can. This stuff, be careful, the fumes on it in an enclosed space will get you a little bit high. But yeah, on that dental hygienist theme here, the toothbrush works really well getting in there and going over things. Just a little tip there. Okay, yeah, just quickly talking about the color of the wiring within these chassis. There's a rhyme of reason to this, and there is sort of a standard that apparently was supposed to have been followed, but it does seem to vary from manufacturer to manufacturer, and the standard may have changed certainly after the war. Maybe where a product was limited, they may have just used wiring that they had on hand. So roughly, it's this, as you can see here. I've drawn up. Black is supposed to be used for grounds and grounded elements. I find that to hold pretty true with most radios. The brown is supposed to be filaments and off ground. The red, the power supply, B plus. Again, this I find to be pretty much used for most radios. Orange is supposed to be for screen grids. Yellow for cathodes. Green for control grids. Blue for plate. Gray for the AC power, and white for ground returns, automatic volume control, etc. So they seem to use the white, just sort of miscellaneous. The problem is that a lot of times they don't follow this, and the other problem is, okay, what color is this? These have actually faded so much. I mean, is that blue or is that green? Well, that's probably green. Now, green is supposed to be used for control grids, but in this Zenith, they're using green for a lot of different things here, not just control grids, I can assure you. The red does seem to be used for sort of more hot powered elements, which is pretty good, and the black does tend to be used for the grounded elements. So this can be helpful, if you're trying to determine what the wire does and for doing testing, but don't expect it to always be perfectly accurate, but it's a rough guide for you. Alright, so I said I would point out anything interesting as I go along with this recap here, and come across something a little bit interesting for me. As I said, I haven't done a lot of radio. I haven't done any radios from the 30s before, and this capacitor here, very interesting the way the leads are, the style of the leads. Usually the style of the leads are just solid core wire. These are the actual leads that come out of this this old cap was this braid strap, very very thick kind of braid strap. Usually you'd see maybe connecting a ground lug or a ground strap, and they were actually part of this. This capacitor. So this is the capacitor that will substitute for this old one. So you can see here it's quite a long distance to go. So I was trying to think, well, I showed you the trick with the J hooks earlier. Well, how do we connect this this new capacitor here? So what I decided to do is I used a very sharp the bit that comes with this Heiko, used to clean the head of that, is very very fine, finer than a bit that you'd find at Home Depot or such. And I used, you can't see it now because I think I dropped this and I broke it, so it's somewhere on the floor right now, but it's very sharp, and I used that to let's see, where am I, to add a bit of a hole here. Let's see if I can focus on that strap. So what I'm going to do is I'm going to J-hook the replacement capacitor and hook it onto that. This side here, as I tried to put the hole in, it kind of came apart. So I don't think I'll get back to this, but just kind of an interesting capacitor, and showing you what I'm going to do to attach the new capacitor there. I said I wouldn't get back to this capacitor, but it's kind of neat, just showing you what I did here. I've got the one side that worked really well, just punching a small hole in the braid, getting the J-hook through there. You can see here, this capacitor originally had a piece of insulation in there to protect it, and you can see why. You've got this other terminal from the tube here. You definitely don't want those to touch. So what I did is, before I put this together, I put a piece of heat shrink tubing here, slid it to the side, and now what I can do, that it's joined together, I can push that shrink over there. Okay, you can see we have a nice covering, and I'll put my little blower on there. The what do you call that thing? The heat gun on there, and that'll shrink right down and make a nice bond. I also put a smaller piece here before we started to protect this part of the capacitor lead. Did it in two parts because that way I was able to sort of slide it back and then put it in position with the smaller one here. So that worked really well. All right. Tucked in behind here, connecting to this pin of the tube and the ground lug, was a this is kind of a tight spot. Was a this capacitor, and they had wrapped the leads of this resistor or capacitor. I think that's a resistor. I know there are some capacitors that actually look like that, but I believe that's a resistor. At any rate, I'll have to check the schematic. Wrap the leads of the capacitor, this capacitor here, around the leads of this resistor. So I opted to just cut the resistor out as well. And you can see I haven't soldered this yet, but I did the same. I wrapped the leads of the resistor and the capacitor together, and that's quite a distance in there between the two join points. So I used some just kind of a trick too. You can use some 18 gauge solid core wire, strip that off, you know, and you're left with these longer leads. Again, J hook here, J hook there, J hook, J hook. So once this is soldered together, this should be a good connection. Left these leads nice and long here so I can get in there and wrap them around the post as needed. And there's not a lot going on back there, but for this to touch, but probably just clean it up and put a little tubing over this to dress it up a little bit. Okay, and here we have the finished result with the heat shrink tubing in place. All sorts of funky old things in this this old Zenith here. This is interesting. There's a capacitor I'm about to remove and replace, and they have it harnessed down to the chassis here with this strap that wraps around the old capacitor. Soldered in place, so it's nothing I can unscrew at this point. I'm going to make an attempt to salvage this. I think I'm going to do is I'm going to try to cut this with the sharp my sharp cutters and the pinchers, and see if we can't retain that. I have come across, this is probably just to keep it securely in place because it's such a long distance, but it could have some shielding properties as well. Probably not because it's not going the whole length of the capacitor, but I did run into another capacitor a while ago with, it had a sort of a third lug to it, and it had in addition to the foil, it seemed to have an additional actual shield around it. Maybe just and it really was intended to boost the shielding of the capacitor, and that actually had a third wire connected to that, and that went to the ground strap. That one I tried to recreate with using some adhesive foil. I wrapped it around and soldered a bare piece of wire in there, extended it out, soldered it to the connection point, and wrapped it all up in heat shrink tubing. I don't think this is that, but still I don't want to just take this harness out here. I want to try to utilize that because we do have a long length here, and we can use that to fasten down the new capacitor. So yeah, after cutting that, this is what we're left with here. Seemed to work out well. You can see it's kind of riveted on there. All right, so I'm going to put the new capacitor in there and see if I can use this to support it. Oh yeah, this is what I've done. I'm not sure how I feel about it for a couple of reasons. Boy, oh boy, look at the distances that they had to travel with this old radio. I've never seen such a long distance for a capacitor leads to spread. So again, I've got a lot of J hooks going on over here to connect this capacitor because the new ones just don't have leads that long. So, you know, as mentioned, I wanted to keep the strap here. I did. I folded it over. Doesn't really need it, you know, as far as securing the capacitor because this is so light, and I've got the leads all dressed up. It's, you know, really not necessary. I did include it just because, just sort of a nod to the old one. It's in here. I'd hate to take it out. Obviously, I squash it down to go over it, and I, you know, the only thing that concerns me a little bit that I don't love is that the potential connection point here between the two leads on the capacitor with the metal strap. But you know, I got up really nice and tight with the heat shrink tubing on the lead, so those aren't going anywhere. So that should prevent any shorts going on. And in the event that this is providing any shielding, maybe perhaps because the leads are so long. Again, I don't think that's why the purpose of the strap, but at any rate, the strap, which is grounded, will obviously help prevent and shield the capacitor. So I'll leave it that way for now. As I work on changing the capacitors in this chassis, it occurred to me that I really should be looking to see if any of these capacitors require what's called a safety capacitor. And a safety capacitor is used a little different construction than a typical capacitor. They're made to a higher level so that if they fail inside, the capacitor will stay open. Let me see if I have an example of some safety caps here that I've purchased. These are all safety caps in here. So again, they're made to a higher standard so that if they fail, I think they're fire retardant for one, and if they fail, the circuit stays open and they don't short out. That's important because you want to use these where the AC coming in is directly connected to the chassis. What can happen is if some of these older radios that they use capacitors directly connected to the AC coming in to the chassis, and you know, I think they do that to prevent hum, etc. But if one of those were to fail, a normal capacitor will short out, and it'll send the full voltage to the chassis and to other circuits within the radio. So it can be quite dangerous. So I'm looking through the schematic here, and I don't see that being used here. You can see with the AC supply goes right to the switch and then right to the transformer, both sides of that, and confirm that sort of looking here, following the lead. So no direct connection to the AC to the chassis here via capacitor, so no need to use these. Whether or not that affects the performance of this radio, perhaps there'll be a bit more hum. We'll have to see. You know, it does have the electrolytics, that this large can that we rebuilt, and these are done to you know, to smooth out the rectified AC signal, so you don't get the peaks in there. Maybe that will help with the hum as well. And just an example of what they look like in circuit. Something like this, you can see the AC is coming right in. You can see this is two capacitors directly connected to ground. If one of these were to fail, you're going to have some trouble. Sometimes it's on both sides of the AC line. Sometimes it's on just one. And then you have other ones where that actually bridges the two sides of the AC line. So again, you would want to have that. Okay. Just want to clarify something that I just said. I think I mentioned that the electrolytics are used to smooth out the rectified AC signal, but that's actually incorrect. It's the DC at this point that it goes into the electrolytics, and that's used to smooth out the signal. It's kind of, you can see my notes here on that. What the capacitor does is kind of once you rectify the signal and you remove the bottom layer of the AC, the bottom portion of the wave, you're left with just a DC signal like this, and then you just have the peaks from that, and the electrolytics are used to sort of smooth that out. They kind of hold on to the charge and slowly release it, so what you end up with is a solid DC signal. So that's what the electrolytics are being used for here. And you can see that on the schematic coming in after the transformer. They're used here to smooth out the rectified DC signal and pass it on to the rest of the radio. I mentioned before that my notes and schematics didn't list based on the number of the capacitor. I had mentioned before that the C2, there was nowhere in the literature that told you what C2 was, but it's right here in the schematic in this little section here. I didn't notice before, so it is here. Very handy. You can see that one that was in question is listed here as C2, part number 250, I believe, 0.05 microfarad, 200 volts. So that was listed here. Okay, more strange and interesting things I'm finding with this old Zenith. This one's kind of baffling me. I noticed when I first got this radio and I was looking at the chassis, this piece of paper in here. At first I thought it was maybe a light shield or something. Sometimes they, it's pieces of paper in these old radios to sort of block the light from the bulbs from going where they don't want them to go, and they have paper. And a lot of times that paper's, it's either been removed or it's deteriorated. So I thought maybe this was a piece of that, but I saw the way it was placed, and I realized it was actually being used to, let's pull it out here, being used to prevent this spring, which I really don't completely understand the purpose of, from making contact with this terminal here on the volume pot. So it's funny, you open up this piece of paper and it's kind of like a fortune. What do we have here? And look at that. It's interesting. This doesn't look like it's from the manufacturer. It looks like, again, a repair person or an owner at some point way back grabbed a piece of their 1941 calendar, ripped out an edge of it and folded it up and shoved it in there. They must have been getting some type of a noise or some type of interference from the friction of the spring in there. So yeah, I don't like that. That's not the way I roll. So pulled this out of here and took the spring off. And boy, I'm really kind of heat shrink happy here today of using heat shrink for everything. So I found a nice piece of heat shrink, took the spring off and put that around the spring, put the gun on it, shrunk it down, so that shouldn't cause any more issues. I've got to look into further about what exactly is going on here. This spring puts tension on this mechanism here for the tuner, but I'm still not sure I understand the purpose of it. If I find out more about that, I'll let you know. I've removed all of the paper wax capacitors from the radio here. These are the old guys. This one included. And getting ready to move on to the electrolytics, including this can that we rebuilt in a previous video. This electrolytic here replaces this tall narrow one underneath. You can see it here. That's just a single capacitor. That's already been replaced, as I mentioned. I'm going to elect to do what they did here and just take this old electrolytic out, which was also a replacement, and replace it in a similar fashion with an axial electrolytic. Hopefully I have a 12 microfarad that'll fit in there and be the proper voltage, etc., etc. This is a good example of, be really careful when you're replacing capacitors. This can be very confusing. This is a different type of capacitor. This yellow-orange one here is an electrolytic versus the wax paper ones, and you cannot replace these with the same type. These are non-polarized and these are polarized. And what's more confusing on this one is that, well, they both have these black bands. Now, again, these wax papers, the actual capacitor itself is not polarized. You can put it either way. This just denotes where the shield is, and generally you want that towards the ground, again, just to reduce hum and interference on the capacitor. But if you were to put it in backwards, it would still function, and you really wouldn't have much of an issue. Again, you might have some more interference. This electrolytic electrolytic, confusingly, has the positive side marked with with a black band. You know, generally you would think a black band. Well, that's negative, and in fact, this black band here with the shielded side generally does go towards the ground portion of the chassis. So this is not the same as this. As I said, this is an electrolytic, and this band does not denote the shield side nor the negative side. No, it actually denotes the positive side of the electrolytic. So, you know, be very, very careful when you're replacing these capacitors. Make sure you really do your research so you know what you're dealing with. Just a quick scan of the capacitors that I've replaced so far. Looking good. I always like the way it looks with these bright, shiny new capacitors in there, and the chassis is starting to get cleaned up, so it's starting to look great. Yeah, real quick, I wanted to mention this in the last clip, but I neglected to. You know, why with this one did I not choose to do the same and have the you know, the new capacitors on this part of the chassis as opposed to, you know, stuffing, which I did. I went, you know, stuffed it into here. Well, usually I would do it because these are multi-caps, and then you can have quite a few of the capacitors coming out of this side, and it can be difficult to fit all the capacitors. If this was replacing 2 or 3, they can really start looking kind of weird and disrupting the sort of the old-fashioned look of this. This one just really was originally 2, but we just replaced it with 1, so it would have been fine. This wouldn't have made a big deal if I had connected these leads together here with the new capacitor and just left this on top. So that's why, and this one is, again, this is only replacing 1 capacitor as well, so that looks fine like that. So again, a lot of times the reason why you'll elect to not put the replacement electrolytics on the chassis side is it's, you know, just to keep a less cluttered look, and to, you know, just, you know, you've got this space created by these cans on the other side of the chassis, so, you know, sometimes it's just nice to use it. One nice thing too is, you know, if I did just jump a capacitor here, you know, these kind of these lugs are kind of, these cable wires are kind of free floating here, so, you know, I'd have to find a way to brace it down. So, you know, by using the can itself, you know, it's going to keep these wires in place where they belong. You know, another thing you could do is you could so to do that, if I wanted to use these brackets on the terminals on the capacitor, to do that I would still need to open this up anyway to sort of disconnect any connections within here. You know, it's probably fine sometimes too. You could leave the old ones in place, but I would still rather to disconnect them completely rather than leave them in circuit. But, you know, that is another possibility, is just to sort of bridge your new capacitor over the old ones. But I don't think that's ideal, particularly if they're shorting out. Okay. Before I install this electrolytic can capacitor that we rebuilt, I'm going to leave this area open because we have to start looking at this variable capacitor here. It needs to be cleaned out for one, and so I'm going to lift it out. We clean under there, clean this out, make sure it's working properly. This is all connected to the dial plate in the front, so we may have to disconnect the cables for the dial in here with the strings, and that will have to be put back together later. So I'll have to see how that goes. But actually, the real reason why we need to remove this is that the variable capacitor, this is used for tuning obviously, is sitting on these rubber sort of grommets here, and it's supposed to float on there and not make contact with the chassis. Those have completely disintegrated, as you can see, and they've kind of bled and made a mess all around the side here. I started chipping away at it, but so we need to lift this out and replace those grommets with some new ones, so that this will float on there correctly. It's interesting too, a lot of times these dials are oftentimes floating on grommets like that, and over time the dial will start sinking downwards. So as you're looking at the radio from the front, all of a sudden what was here is now down there. So it's the kind of the case of the incredible shrinking dial with these over time. All right, so and then let me see, I can flip this over real quickly. You can see that on the, where is that? A little dark here, with the light on it. Grommets here on this side as well. So there's grommets on both sides, and again, these have completely deteriorated. So let me start working on that now before I put that last electrolytic in there. This is the other electrolytic I talked about, the 12 microfarad 450, so that's tacked in. So I believe that's it, other than the last electrolytic. As I said, we're going to wait to put that in so I can leave this area free. After that, once we get those grommets in there and get everything cleaned up, I'm trying to see what other kind of work this may need. We're going to need to do the speaker cone, obviously. Speaker does work. I have listened to it. I wasn't able to get any music in this, obviously, but we did get a sound through it, so it does work. The field coil in there is working, etc., etc. So we'll need to work on just repairing the cone. I'm not anticipating doing a full cone, replacement. Just going to sort of patch it up. Trying to think what else. That may be it. Oh, you know what else we'll do before we fire this up is I want to. Well, this radio here, because of the transformer, I'm going to check the circuit again and see. A lot of times what I do is I'll rewire these so that that there's no way that the AC can be directly coupled to the chassis, to the hot side. The hot side of the AC cannot be coupled to the chassis, and usually rewire it so that the switch will turn off the hot. That way the neutral side is always connected to the chassis. I'll look at the schematic on this and see if that's going to benefit this or not. Having the transformer in there obviously serves as a bit of as isolation. The other thing I usually do though too is I put a fuse in there somewhere. Not a bad idea in case there's a short. So we'll definitely be doing that. Okay.